Okay, so moving on to question number 3. The diagram shows the electrons are arranged in an atom of oxygen. You're being told here you have an atom of oxygen. You can see the arrangement of the oxygen is 2, 6. Okay, 2 in the first shell and 6 in the second shell, 2 of which are paired and 2 are unpaired. Oxygen atoms form both covalent and ionic bonds. Water is formed when 2 atoms of hydrogen combine with 1 atom of oxygen. Draw a dot and cross diagram of the molecule of water. You need to show the electrons in the outer shell. Okay, so I'm just going to go through the answer on this side of the page first, okay, because this is the most correct answer, but it will actually accept either at GCSE level. So we see we've brought our oxygen down, we've got 2 paired and 2 unpaired, so there is our 6 on the outside shell. We're now going to add on our hydrogens here and here, so we've got oxygen in the middle, hydrogen here, put a dot from each of the hydrogens. So you see you have 8 in total, counting them up, 1, 2, 3, 4, 5, 6, 7, 8. 8 on the outside shell, filling the second shell, and 2 on the first shell here, filling the hydrogen shell. Okay, so that is a V-shaped molecule, V-shaped. Okay, so that is the most correct answer. However, you would also be allowed to have it in this way here as well, where you had your hydrogens on each side and oxygen in the centre. This would also be acceptable at GCSE, but we'd prefer you to do it in the V shape here, because that shows a knowledge of the shape of the molecule as well. Okay. Explain how the covalent bonds in the water molecule hold the hydrogen and atoms together. So this is just asking you to explain how a covalent bond holds atoms together. Okay, so it's just telling you to explain what a covalent bond is and how it holds things together. Okay, so we always write the same thing for these kind of questions. So we would start by saying there is a strong electrostatic force. Okay, so first part of the question is answered there for your 1 mark. Strong electrostatic force of attraction. Then you have to say what it's between. So it's between the shared pair of electrons and the nuclei of both hydrogen and oxygen. Okay, it's Y-G-E-N. Okay, you get your final mark for those 2 parts to say what the attraction is between. Moving on to question number 3, part B. The electron configuration of sodium is 281. Sodium oxide, Na2O, is an ionic compound formed when sodium reacts with oxygen. Describe in terms of electrons what happens when sodium oxide is formed in this reaction. So it's asking you to describe the formation of an ionic compound, specifically sodium oxide. So how are ionic compounds formed? Okay, so the first thing you have to talk about is the idea of an electron transfer. Electron transferred from. Now, what is transferred to what? Because say we have 2 sodiums in this, so 1 sodium gives 1 electron to 1 oxygen, and another sodium gives 1 electron to the same oxygen. So you have to write down how many transferred to what. Okay, so the direct transfer of sodium to oxygen, sodium loses and oxygen gains. So the second part was to say that sodium loses and oxygen gains. Sodium loses 1 electron, oxygen gains 2. So that is actually the full answer there, because sodium loses and oxygen gains would be for the second mark, and to have the correct number, sodium loses 1 and oxygen gains 2, that's what gives you the 3rd mark. Okay, so the next question is, a teacher added sodium oxide to water in a beaker. The equation shows the reaction below. So the equation shows the reaction that occurred. Sodium oxide and water to give you sodium hydroxide. Insert the appropriate state symbols in the reaction. So we know sodium oxide is a solid, so we're going to write S here. Water is always a liquid unless stated in the question that it's a gas or it's steam. And then sodium hydroxide, we know from our acid-base theory, is an aqueous solution of an alkali, AQ. Okay, so that was your marks for your inserting the appropriate state symbols. There was 2 marks for that question. The next mark is 2. Some universal indicator is added to a beaker. A colour change occurred. State the final colour change of the universal indicator and identify the ion very specifically, responsible for the colour. So we're looking at an alkali. The alkali is the hydroxide ion. Our hydroxides ion are purple or blue. In a strong alkali is purple or blue. Hydroxides are strong alkalis. And the ion responsible is OH minus or hydroxide, written in words.